Okay, so for this bell work question, it's basically a review from the previous lesson. So in the previous lesson, I wanted you to know what G of 4 means. G of 4 means go to the G problem and plug in x equals 4 into the problem. So the G problem is this, so we're going to substitute it out and put in 4. We'll type all that in our calculator, and we get 19. That's our answer. Part 2. Part 2 is similar, except it's a different name. So that's the function f. And this time they wanted to find f of 19. So that means to plug in x equals 19 into that problem. So you end up with negative 2 parentheses plus 32. Put in the 19. And then you end up with negative 6. Now, believe it or not, I've actually tricked you into doing today's notes. So the stuff that I'm about to teach you, what you didn't know is it's called composition of functions, and all it is a two-step problem where first you find an answer, and then you take that answer and you plug it into the second problem. So we're going to make a small adjustment to our notes here in a second, but a composition of function is just a two-step problem. Now the big thing is you've got to make sure you understand the directions. That's a big thing in all classes. So we're going to take this off because that's actually for the next set of notes. And we're going to talk about what this means. F of G, oops, actually I'm going to change that like this. Actually I'm going to change it a little bit more. F of G of, I'll just make it 2, whatever. So first thing is teaching you how to read it. So this is a two-step problem. And when we do this, we have to start from the problem that's on the inside. So this is step 1. Step 1 is plug in G of 2. Once you find the answer, you're going to take that answer and plug it into the F problem. So step 2 is plug in the result, which is essentially what you did in develop. So I'm going to actually work this problem out. I'll break it up into 2 steps. I'll try to color code it so it makes sense. So step 1. Step 1 is find G of 2. We know from yesterday's notes that we're going to use the G function. So it's 9 take away parentheses, and we want to plug in 2. We work this out, it gives us 7. So step 2 is to take that result and now put it into the F function, because that's what our direction said way over here. So now we're going to go into F, and we are going to take that answer and put it in. So F of 7 is parentheses squared, put in the 7, work it out, and our final answer is 49. So when we write our final answer, this has 2 parts to it, but we only care about this final answer. So here's another one. So first, how do you read it? What do you do first? We have to do G of 5 first. That's step 1. So step 1 is find G of 5. So G of 5 is square root, parentheses, plus 11. We'll put the 5 in. We worked all that out, we do it in the calculator, and we get 4. Step 2, second, put the result into the F problem. So the F problem is now going to have the 4 in it. So we have 2 parentheses squared minus 3. And then we put the 4 inside. Do all that in your calculator. 16, 32, end up with 29. 29 is your final answer. A few more examples. Again, they're just 2-step problems. You have to start with the one on the inside. So step 1 is find G of 2. So this time, if you notice, we have 3 different problems. So they have 3 different names. So we have to start in the G problem, and we have to plug in 2. So G of 2 would be 3 times 2, which is 6. And then the second part of this is to take that result and now put it into the F problem. So now we're going to find F of 6. So the F problem is 2, parentheses minus 1, with the 6 on the inside. 12 minus 1 is 11. That's our final answer. Start with the innermost function. So we're going to do step 1 is h of 3. The H problem says square it and then plus 1 to it, so we put in 3. 9 plus 1 is 10. So the answer to step 1 is 10. Step 2 is to actually plug that in to the second problem. That's our second problem right there. Second. So the F problem, we want to put the 10 inside of it. So the F problem says 2 times parentheses minus 1. So we put the 10 inside. So we end up with 19. That's our final answer. Here's step 1. Step 1. So we're going to do H of 7. The H problem says x squared plus 1. So we put the 7 inside. That gives us 50. Now step 2, here's step 2. Step 2 is to take that result and put it into the G problem. The G problem says, put that in there, 50. The G problem says 3 times x, so we put the 50 inside of it. So that gives us 150. Guys, you can get big numbers. I mean, it just depends on the problem. 150 is okay. You'll get some problems in the assignment where you're going to get 0, and that's okay too. Now, what you are going to have to do, because the test is going to do this, is you're going to have to tell the difference between the different types of problems that we've worked on so far. So if you notice, down here in this second section, these directions right here, they're different. They don't look the same as the last one. The last ones, we had F, and then G, and then a number. These ones are a little bit different, because now they have this plus sign in the middle. That's actually from the last set of notes that we did. So this does not mean to multiply the problems by 2. This means separate them, f of 2 plus g of 2. So instead of being a 2-step problem, this problem requires us to get 2 separate answers and then add them together. So I'll do that in 2 different sections here. I'll use different colors so you can see the difference. So f of 2 means 9 take away 2. So that's 7. G of 2 is something squared plus something else, because we've got the 2 x's right there. So we're going to put the 2 in. If I type that in the calculator, I end up with 6. The last part of these instructions says find those 2 results and then add them together. So our final answer in this question is 13. So you can see it's a little bit different because we're doing both problems at once, whereas before we would do one step and then put it into the other problem. Again, h of 0 minus f of 0. So h would be 0 minus 2. So it's negative 2. F of 0 is 9 take away 0. So that's 9. And then the problem says subtract that. Negative 2 take away 9 is negative 11. That's our answer. Now the next problem says g of g divided by h of 2. So really, remember, this really means g of 2 over h of 2. So I'm gonna bring it over here. The g problem is parentheses squared plus parentheses, and then we put in the 2, which we know the top is going to be 6. Very good, that over here. The h problem is right here. It says x minus 2, and we still put in the 2. So we get this issue here where we get 0. Now, you should type it into the calculator because the calculator says math error. When that happens, we actually do not write this. Instead, we write undefined. There are certain times in math where numbers don't work. And when those numbers don't work, we say that they're not in the domain. So the value of 2 is not in the domain because it causes the function to be undefined. That means that 2 is a bad number because when you type it in the calculator, it doesn't work. The calculator cannot actually come up with an answer. Now, I wanted to go back a little bit and talk more about domain like we did before in the last set of notes. I just want to make sure I'm very clear on this. A lot of functions that we work with in Algebra 2 have a domain of all real numbers. That means there are no bad numbers. We can use any number, plug it into the problem, and the calculator should give us an answer without saying math error. So what I need you guys to understand is if a problem has a domain of all real numbers, kind of like this. If this problem right here has a domain of all real numbers, and so does this one, which they both do, that's actually true. Each one of those has a domain of all real numbers. If I do addition or subtraction or multiplication between those two, the result is going to be all real numbers. So that only works with addition, subtraction, and multiplication. If the original problem has a domain of all real numbers, which a lot of problems do, then any arithmetic you do between those two problems should also have the same type of result, all real numbers. There is one time, however, where that does not work, and I'm going to teach you that now. So right here, it says what value of x are not in the domain. Basically means that that's telling us that there's bad numbers. There's numbers that do not work. So what we're going to do here is first set up the problem. They want the f problem on top, so 3 minus x. They want the g problem on the bottom, so 3x minus 1. And you saw up in this problem, up on the top right here, in this problem we saw that the bottom of a fraction cannot be 0. That causes problems in the calculator. So if they're asking us what are the bad numbers that makes that happen, we can only find it if we have a fraction with an x on the bottom. So this is the part that's going to mess everything up. So we take that. To find the bad number, we take 3x minus 1, and we actually set it equal to 0, even though we don't want it to be 0. So we're going to find the value that makes that happen. So if I add 1 to both sides, that's 1. And I divide by 3, so x equals 1/3. That's my bad number, because if I go back in here and I put in the 1/3, this entire value right here is 0, and that is not allowed. That is undefined. So when it says what is the value that's not in the domain, here it is right here. X equals 1/3 is not in the domain. Why? Because it's a bad number. You type it in the calculator, and the calculator will spit out math error. Now, that's the only time that happens so far. In a division problem, basically a fraction, where x is on the bottom. So that works with all problems like that. So let me just go to a different page for a second. Let's say I have x plus 4 over 3. If I asked you what values are not in the domain, this doesn't have any issues. Now, I know it's a fraction, but it doesn't have an x on the bottom. The problem is the bottom can't be 0, and there's nothing that can make this a 0, because there's no x's interacting with it. Now, if I was to take the 3 and put an x next to it, let's say that was the original problem, now we have an issue. So how do you find the bad number? You take this guy, set them equal to 0, and solve. So x equals 0 is the bad number. So x equals 0 is not in the domain. Every other number would work if we plugged it into the calculator, except this one right here. Okay, the last thing, it says what are not in the domain, what are the values that are not in the domain of f times g of x? So remember, this is f of x times g of x. Well, if you remember in the beginning of this, I said f of x has a domain of all real numbers, g of x has a domain of all real numbers. If you add, subtract, or multiply them together, the result will have a domain of all real numbers. So basically, there are no bad numbers. So when it says what values of x are not in the domain, heck, all values are in the domain. They're in the domain. What does that mean? It means there's no bad numbers. Every single number that we try will actually work when we type it in the calculator. And the cool thing is, like, you don't have to work it out. If you know that fact, you don't have to do the work. You don't have to multiply them. So for your assignment, I'm going to have you guys, this is, what is this? 0.2, I believe. So for your assignment for 0.2, in the packet, you guys are actually going to do problems 1 through 17. So number 1 through 17. And that's it for composition of functions. Now, Monday, we're going to go much slower because we're going to do a different version of composition of functions. Our composition of functions on Monday isn't going to have numbers in it. It's going to have expressions like x plus 4 or 5x minus 3. You can think of it as plugging one problem into another. So to be honest, that for a lot of students is the most difficult lesson of the entire chapter. But I'm going to slow down. I'm going to do a lot of examples, and I'll make sure that you get it by the time we're done.